Dear students, let us continue our discussion on limits. Let's have a look at the next question. Okay, question 69. Limit n tends to infinity 2 to the power 3n divided by 3 to the power 2n is equal. Limit n tends to infinity 2 to the power 3n divided by 3 to the power 2n. If I directly apply the limit, we are getting 2 power infinity, that is infinity, divided by 3 power infinity, that is also infinity. Infinity by infinity is an indeterminate form. So if you want, you can use L-Hospital's rule, or else we can directly solve this. So that I will explain. Limit n tends to infinity. This 2 to the power 3n can be written as 2 cube whole power n. In other words, 8 power n divided by 3 power 2n, that is 3 square whole power n, which is 9 power n. That's equal to limit n tends to infinity 8 by 9 whole power n. 8 power n divided by 9 power n can be written as 8 by 9 whole power n. So limit n tends to infinity 8 by 9 whole power n. See, look at this fraction 8 by 9. 8 by 9 is less than 1. When the fraction is less than 1 and then when the power increases, the value of that fraction decreases. And by the time this power reaches infinity, when the power reaches infinity, if that fraction is less than 1, then the value of this limit is equal to 0. Okay? So you have seen limit n tends to infinity x power n is equal to 0 whenever mod x is less than 1. If this fraction is less than 1, then as the power increases, the value of the fraction goes on decreasing. And by the time it reaches infinity, the value of the fraction becomes 0. So 0, first option, is the answer. Next. Question 70. Limit x tends to infinity x cube by 2x square minus 1 minus x square by 2x plus 1 is equal. Here if I directly apply the limit, look here, x cube by 2x square minus 1. If you consider only that term, then numerator has a larger degree. See, you can write the given problem as limit x tends to infinity x cube by 2x square minus 1 minus limit x tends to infinity x square by 2x plus 1. Okay? So now what happens? Observe that numerator has a larger degree. Degree of the numerator is greater than the degree of the denominator. When you have limit x tends to infinity f of x by g of x, where f and g are polynomial functions with the degree of f of x greater than the degree of the g of x, then the value of that limit will be infinity. So this will be infinity. Similarly, this will also be infinity. The numerator has a larger power, so this will be infinity. Then what will be the final answer? Infinity minus infinity. Infinity minus infinity. Don't think that we can cancel infinity and we will get the answer as 0. No, that's not correct. Then marks will be 0. Okay? So infinity minus infinity is an indeterminate form. So we cannot solve it in that way. Let us say any other method. So we have minus x square by 2x plus 1. Okay. Let us simplify this. I will take LCM here. LCM is 2x square minus 1 into 2x plus 1. This is the LCM. The numerator will be x cube into 2x plus 1 minus x square into 2x square minus 1. Okay? X cube into 2x plus 1 minus x square into 2x square minus 1. That's equal to limit x tends to infinity. Here in the denominator I will just simplify. 2x square into 2x, that will give you 4x cube plus 2x square minus 2x minus 2. Then numerator what happens? 2x to the power 4 plus x cube minus 2x power 4 plus x square. So this 2x power 4 gets cancelled. We will have limit x tends to infinity. 2x power 4 gets cancelled. We are left with x cube plus x square. Okay. Denominator is 4x cube plus 2x square minus 2x minus 1. That's equal to. Okay. Now you observe, this is of the form f of x by g of x, where f and g are both polynomials of the same degree. F and g are both polynomials of the same degree. Then what is the answer? As x tends to infinity, when both are polynomials of the same degree, then the answer is highest coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. So this will give you 1 divided by 4. 1 by 4, which is the fourth option. Okay. Then question 72. Limit x tends to infinity x to the power 3 by 2 into root of x cube plus 1 minus root of x cube minus 2. Okay. As it is, if I apply the limit, we are going to get, so x power 3 by 2, this will become infinity into cube, root of infinity is infinity minus infinity. Okay. This is an indeterminate form. So here we have square root of x cube plus 1 minus square root of x cube minus 2. I will rationalize this. That is, I will multiply and divide by root x cube plus 1 plus root x cube minus 2. So, limit x tends to infinity x to the power 3 by 2 into root of x cube plus 1 minus root of x cube minus 1 into, so we will multiply and divide by this, root of x cube plus 1 plus root of x cube minus 2. Okay, I am multiplying and dividing by root x cube plus 1 plus root x cube minus 2. Now, this is equal to limit x tends to infinity x to the power 3 by 2 into, here a minus b into a plus b. A minus b into a plus b will give us a square minus b square. What is a square minus b square? A is root of x cube plus 1. So, a square means x cube plus 1 minus b square. B is root x cube minus 1. B square is x cube minus 1 divided by root of x cube plus 1 plus root of x cube minus 2. Okay. So here we had x power 3 by 2 into root x cube plus 1 minus root x cube minus 1. We have rationalized this. That is, we have multiplied and divided by root of x cube plus 1 plus root x cube minus 1. And in this step, a minus b into a plus b, that will become a square minus b square. Now on simplification, this will become x cube plus 1 minus x cube plus 1. X cube gets cancelled. 1 plus 1 will give us 2. So this is equal to limit x tends to infinity 2 into x to the power 3 by 2 divided by, this will give you 2 into this x power 3 by 2 divided by, here I will take x cube as a common factor. Okay, that x cube as a common factor I will take. That x cube I will bring it outside the root. When x cube comes outside the root, it will become x to the power 3 by 2. Okay, into root of, here I have taken x cube as common, so we are left with 1 plus 1 by x cube. I have taken x cube as common, so you get x cube into 1 plus 1 by x cube. Then this x cube I have taken out. When it goes out, it will become x power 3 by 2 plus. I do the same thing in the next term also. Here also I am taking x cube as common. When that x cube goes outside the root, it will become x to the power 3 by 2 into root of 1 minus 1 by x cube. Okay. Now in the denominator I will take x power 3 by 2 as common. Then this x power 3 by 2 gets cancelled. After that we are left with, I will continue here, that's equal, we are left with limit x tends to infinity. Numerator contains 2 and the denominator contains square root of 1 plus 1 by x cube plus square root of 1 minus 1 by x cube. Now as x tends to infinity, 1 by x cube becomes 0. So this will be 1 plus 0. 1 plus 0 is 1, root 1 is 1. Here 1 minus 0, that is 1, root 1 is 1. 1 plus 1 is 2. Numerator is 2, denominator is 2. So the answer 2 by 2 is equal to 1. Okay. 77th question. Limit n tends to infinity sin n theta divided by root n is equal to sin n theta by root n. Okay. I will rewrite the given problem in this way. Limit n tends to infinity 1 by root n into limit n tends to infinity sin n theta. It is like if you have a limit x tends to a f of x into g of x, you can apply the limit separately and multiply. You can write it as limit x tends to a f of x into limit x tends to a g of x. Okay. So I am writing limit n tends to infinity 1 by root n into limit n tends to infinity sin n theta. Okay. Now as n tends to infinity, 1 by root n, this will tend to 0 into, as n tends to infinity, what happens to sin n theta? So it's as good as limit x tends to infinity sin x. Say this limit does not exist actually. Limit x tends to infinity sin x does not exist because we know that sin x, its value of sin x is something between minus 1 and 1. But as x tends to infinity, we only know that it lies somewhere between minus 1 and 1. We don't know what is the exact value of it. We know that it is a finite quantity between minus 1 and 1. So I can write this 0 into a finite quantity between minus 1 and 1. Finite value between minus 1 and 1. Right? See, as it is, only if I give you this much, then the limit does not exist. But when you have 0 into that, then the limit exists because 0 into the finite value is equal to 0. First option is the answer. Next. Limit n tends to infinity n by n plus 1 whole power n is equal to. Okay. So here, this problem can be solved in two ways. I will give you both the methods. See whichever is easy you can follow that. First one, you know this formula. Limit n tends to infinity 1 plus 1 by n whole power n is equal to e. You know this formula, right? I think I gave it in terms of x, now it is in terms of n, no problem, 100%. Limit n tends to infinity 1 plus 1 by n whole power n is equal to e. Whatever we have here, its reciprocal should be there in the power. Here 1 by n is there, so its reciprocal is n is equal to e. Okay. Now first I will solve it by using this formula, and afterwards I will give you another formula. Okay. I want to use this formula. So what I do is, in the given problem there, I will write it like this: n plus 1 minus 1 divided by n plus 1 whole power n. I am adding 1 and to compensate it I am subtracting 1. Now I will split this into two terms. I can write this as n plus 1 by n plus 1 minus 1 by n plus 1. Okay, that will give you 1 minus 1 by n plus 1 to the power n. Okay, then see now n tends to infinity 1 minus 1 by n plus 1 we have. Earlier I have told you that whatever we have here, its reciprocal should be there in the power. That is, here we have plus 1 by n, so the reciprocal is n. Here we have minus 1 by n plus 1, its reciprocal is minus of n plus 1. We have only n here, I want minus of n plus 1. So what I do here is, I will write it in this way. Limit n tends to infinity 1 minus 1 by n plus 1 to the power, I will write it as minus of n plus 1 minus 1 into minus 1. Is it okay? See what I have done. On simplification, what I do? 1 gets cancelled. Minus n into minus 1, you get plus n only. Okay. Then why do I write like this? Because I want, see here you have minus 1 by n plus 1. Its reciprocal is minus of n plus 1. I want minus of n plus 1. In order to get that, I am doing all this exercise here. Okay. That's equal to limit n tends to infinity, 1 minus 1 by n plus 1 whole power minus of n plus 1 minus 1 into minus of n plus 1 into minus 1 minus 1. See here, minus of n plus 1 into minus 1. Then this minus 1, minus of minus 1 is plus 1 into minus 1 is that. We can write this as limit n tends to infinity, 1 minus 1 by n plus 1 to the power minus of n plus 1 into minus 1 into 1 minus 1 by n plus 1 to the power minus 1. Okay? Just like if you have x to the power m plus n, you can write x to the power m plus n as x to the power m into x to the power n in that way. Now as n tends to infinity, this expression will become e. Observe here we have minus 1 by n plus 1, its reciprocal is minus of n plus 1. So this expression will become e. E to the power minus 1 is there, so it will become e power minus 1. And then here, as n tends to infinity, this will be 0. 1 minus 0 is 1. 1 power minus 1 is 1 only. So e power minus 1 into 1 plus 1, it is not minus 1. Plus 1, e power minus 1, that is nothing but 1 by e. That's the answer. Third option, 1 by e. Okay? This is one way of solving this problem. I'll give you another method. I feel that is easier than this. Okay, I'll explain. It's up to you which one is easy. You can follow that. Okay. Say, earlier while discussing synopsis, I gave you another formula. When you have limit x tends to a f of x to the power g of x, if we have limit x tends to a f of x to the power g of x, limit x tends to a f of x to the power g of x. Suppose if we have this, and when we directly apply the limit, if we are getting 1 power infinity form, then that 1 power infinity form, then we can write this as, this is equal to e to the power limit x tends to a g of x into f of x minus 1. Okay? When we directly apply the limit, if we are getting 1 power infinity form, then we can write that limit as e power limit x tends to a g of x into f of x minus 1. Now we just check whether it is in this form or not. If I directly apply the limit, here n by n plus 1, both are polynomials of degree 1. So when both are polynomials of the same degree, then the answer is the highest coefficient of highest power of x, in this case n, coefficient of highest power of n divided by the coefficient of highest power of n in the denominator. So 1 by 1 to 1, this expression will be 1. What happens to the power? N is tending to infinity, so power tends to infinity. This is of the form 1 power infinity. Then what is the value of that? So I will write that. Limit n tends to infinity, n by n plus 1 to the power n. This is equal to, we are getting 1 power infinity form. Here, in place of f of x, we have n by n plus 1. And in place of g of x, we have n. This is equal to e to the power limit x tends to a. In this case, we have n tends to infinity. G of x means n, into f of x minus 1. F of x minus 1 means n by n plus 1 minus 1. Okay, this is equal to e power limit n tends to infinity, n into, I'll take LCM here, n plus 1 is LCM, numerator will be n minus 1, n gets cancelled, e power limit n tends to infinity, n gets cancelled, minus 1 by n plus 1 will remain, take this n inside, we get minus n divided by n plus 1. Okay, now look at this, limit n tends to infinity minus n by n plus 1. Both are polynomials of the same degree. So the answer is the coefficient of highest power of n divided by the coefficient of highest power of n. Here highest power of n is 1. So its coefficient is minus 1. Numerator minus 1, denominator is 1. So the answer is e to the power, I'll write here, e to the power minus 1 by 1. We can write that as e power minus 1. E power minus 1 is nothing but 1 by e. Okay, next 79th question. Limit extends to infinity 3x minus 4 divided by 3x plus 2 whole power x plus 1 by 3. Okay. Now for this, if I directly apply the limit, I am getting, here you have 3x minus 4 divided by 3x plus 2. 3x minus 4 by 3x plus 2, both are polynomials of degree 1. So the value of this limit, you forget about this, you concentrate only on this base. It will be, both are polynomials of the same degree. So the answer is coefficient of highest power of x divided by the coefficient of highest power of x, which is 3 by 3, that's 1. And the power x plus 1 by 3, that power will tend to infinity. So this is also of the form 1 power infinity. Okay, so we can use this formula, e to the power limit x tends to infinity g of x. In this case, g of x is x plus 1 by 3 into f of x minus 1. F of x is 3x minus 4 divided by 3x plus 2 minus 1. G of x into f of x minus 1. That's equal to e to the power limit x tends to infinity x plus 1 by 3 into, take LCM, 3x plus 2 divided with 3x minus 4 minus 3x minus 2. Okay, 3x minus 4 minus 3x minus 2. 3x gets cancelled. This is equal to e to the power limit x tends to infinity. Here what will remain? X plus 1 by 3 into, here minus 4 minus 2, that will give you minus 6 divided by 3x plus 2. Okay, that's equal. Here 3 gets cancelled, minus 2 will remain into this. I can write this as e power limit x tends to infinity. Here minus 2 is remaining into this, we get minus 2x minus 2 divided by 3x plus 2. Now apply the limit as x tends to infinity. Both are polynomials of the same degree. So the answer is e to the power minus 2 by 3. E power minus 2 by 3, which is the first option. Then, question number 81. Limit y tends to infinity 1 plus x by y whole power y. Here, y is the variable. Y is tending to infinity. X will not go anywhere. X will remain as is. Okay. So, limit y tends to infinity. If I directly apply the limit as y tends to infinity, then this x by infinity. This will become 0. 1 plus 0 is 1. Power 2y is there. Y is tending to infinity. So, the power will also tend to infinity. This problem is also of the type 1 power infinity. When we directly apply the limit, we are going to get 1 power infinity form. So I am using this formula. This is equal to e to the power limit y tends to infinity g of x. G of x means 2y into f of x minus 1. 1 plus x by y minus 1. 1 gets cancelled. X by y will remain. Y gets cancelled. So we have e power limit y tends to infinity to x. See here, y is tending to infinity, so x will be treated as constant. So when y tends to infinity, 2x will remain as 2x only. Hence, the answer is e power 2x. Next, limit n tends to infinity cos x by n whole power n. Limit n tends to infinity cos x by n whole power n. Now if I apply the limit here, x by n, again here n is tending to infinity, so n is the variable, therefore we should treat x as the constant. As n tends to infinity, x by n will tend to 0. X by 1, n will tend to 0, so we get cos 0. Cos 0 is 1. 1 to the power infinity. 1 power infinity. This is also of the form 1 power infinity. Hence, we can use this formula. So this will give us e to the power limit n tends to infinity g of x is n into f of x minus 1 cos x by n minus 1. Okay. Now if I directly apply the limit here, n is infinity, so this will be infinity. This will become x by n will become 0, cos 0 is 1, 1 minus 1, 0. So you are getting infinity into 0. What is the value of infinity into 0? This is also an indeterminate form. Okay. Then what else can we do? I will take this n to the denominator. I will write it like this. Cos x by n minus 1 divided by 1 by n. This n I am taking to the denominator. When it goes to the denominator, it will become 1 by n. So now if we apply the limit, cos 0 is 1, 1 minus 1, 0. Denominator, n is tending to infinity, therefore 1 by n will tend to 0. So this is of the form 0 by 0. When you say 0 by 0, what comes to your mind? Yes, you are right, exactly, that's what should come, that is L-Hospital's rule. Okay, use L-Hospital's rule here. This is equal to e power limit n tends to infinity. Differentiate this cos x by n. Derivative of cos x by n is minus sin x by n. Observe that n is the variable here, so you have to differentiate with respect to n, treating x as constant. Minus sin x by n into x by n, x will remain as it is. Derivative of 1 by n is minus 1 by n square minus derivative of 1, that is 0, divided by, in the denominator we have 1 by n, derivative of 1 by n is minus 1 by n square. That minus 1 by n square gets cancelled. Apply the limit as n tends to infinity. As n tends to infinity, x by n will become 0. So sin 0 you get. Sin 0 is 0. 0 into x is 0. Answer is e to the power 0. E power 0 is equal to 1. Okay. 84th question. If f of 9 is equal to 9, f dash of 9 is equal to 4, then limit extends to 9 root f of x minus 3 divided by root x minus 3 is equal. Limit extends to 9 root of f of x minus 3 divided by root x minus 3. Okay. Now, if I directly apply the limit here, I am getting f of 9, root of f of 9. F of 9 is equal to 9, they have given. So 9, if I substitute f of 9 as 9, root 9, what's the value of root 9? 3. 3 minus 3, 0. Denominator, root 9 is 3, 3 minus 3, 0. 0 by 0, this is an indeterminate form. So I use L-Hospital's rule here. When I use L-Hospital's rule, derivative of root f of x is 1 by 2 root f of x into the derivative of f of x, which is f dash of x, divided by derivative of root x, that is 1 by 2 root x. Okay? This 2 gets cancelled. Apply the limit as extends to 9. So root x will come out. We get root 9 into f dash of 9 divided by square root of f of 9. That's equal to root 9 is 3. F dash of 9, they have given it as 4, divided by root of f of 9. F of 9 is 3. Sorry, f of 9 is 9 and root 9 is 3. 3 gets cancelled. So the answer is 4, which is the first option. Okay, 85th question. If f of a is equal to 2, f dash of a equal to 1, g of a is minus 1, g dash of a is 2, then what is the value of limit extends to a, g of x f of a minus g of a f of x divided by x minus a. Okay. Limit extends to a, g of x f of a minus g of a into f of x divided by x minus a. Okay, g of x f of a minus g of a into f of x divided by x minus a is equal. Here if I directly apply the limit as extends to a, I am getting g of a into f of a minus g of a into f of a. G of a f of a minus g of a f of a, that will be 0. Denominator a minus a, that is also 0. 0 by 0, therefore I can use L-Hospital's rule. Okay. So when I use L-Hospital's rule, here f of a is a constant. F of a means the value of the function at x equal to a. That will be a constant. So when we differentiate, f of a remains as it is. Derivative of g of x, that is g dash of x, minus here g of a is constant because g of a means the value of g of x at x equal to a. So g of a is constant into the derivative of f of x, which is f dash of x. Okay, divided by derivative of x minus a, that is 1. Okay, now if I apply the limit as x tends to a, I am getting f of a into g dash of a minus g of a into f dash of a. That's equal to f of a, they have given, what is the value of f of a? F of a is 2. Then g dash of a is also 2. Minus g of a they have given it as minus 1. F dash of a is plus 1. So we get 4 plus 1, that's equal to 5. Second option. Then 89th question. Let f of 2 is equal to 4. F dash of 2 is also equal to 4. Then what is the value of limit x tends to 2 x f of 2? Limit x tends to 2 x into f of 2 minus 2 into f of x divided by x minus 2. X into f of 2 minus 2 into f of x divided by x minus 2 is. Okay. So now if I directly apply the limit as x tends to 2, here I am getting 2 into f of 2 minus 2 into f of 2. 2 into f of 2 minus 2 into f of 2, that will be 0. Divided by 2 minus 2, that is also 0. 0 by 0 is an indeterminate form. So we can use L-Hospital's rule. Limit x tends to 2. So x into f of 2. F of 2 is constant, will remain as it is. Derivative of x is 1 minus 2 into f of x. Derivative of f of x is f dash of x. Divided by x minus 2 is there, its derivative is 1. That's equal to, apply the limit now, we get f of 2 minus 2 into f dash of 2. That's equal to f of 2 is 4 minus 2 into f dash of 2. F dash of 2 is 4. So 4 minus 8, answer is minus 4, third option. Okay? Students, with this I will stop today's class. In the next class I will discuss continuity and then we will see problems on continuity. You solve all the problems which I have left in between, solve them and check your answer. If you have any doubt, you can always ask in our WhatsApp group. Thank you.